positive, but even if it's not, I'm squaring it. But then I've got Q there, which I know is going to be negative in this case. So whatever I'm going to get negative. So the electric field at this point is going to be negative something r hat. What is the direction if it's negative r hat?
Like if you have a circle that's going towards itself.
Yeah, or towards the center. And I assume your gesture was reference to this specific one, Skylar. All right, so the electric field from the electrons goes this way. So positive charges, the electric field goes out, negative charges, it comes in. You can almost think about it like the positive charges is a water fountain and the negative charges are a drain. Water shoots out of one, goes into the other. So if I had a positive charge here and a negative charge here, the electric field is going out from the positive charge. It goes into the negative charge. And if you figure out the electric field at any particular point, you figure out the electric field from each of them and add them. It's just vector addition. So the electric field at this point is the electric field from the electron plus the electric field from the proton. You find them out separately, add them together. If only we had a lab where we could do that. Ultimately, the final, if you do that everywhere, what you're going to end up with is I got my positive charge here, got my negative charge here, that the electric field is going to go in the middle, straight across, and then it's going to start to curve here. Again, imagine one is a fountain, the other one is a drain. It's basically the pattern of the water. And one final thought. Brilliant. If I have an electric field going to the right, I'm not stating what's causing it, I'm just saying I have an electric field going to the right. And I put an electron into it. Which way will the electron be forced?
To the right.
Why?
Because
It's like it's hopping onto a train car.
I just do it's like opposite to the current.
Is it because the electric field is caused by the proton and it moves away from the proton?
The electrons move away from the proton.
No, I never mind. No, they don't.
Which way is the electron going to go?
Left.
Left. Now, there are three possibilities for creating this electric field. Three simple possibilities. I have a proton over here, creating an electric field going away from it, and the electron is attracted to it. We know it's attracted. I have a negative charge over here, doesn't have to be a proton, some positive charge. I have a negative charge over here, in which case my electron is going to be repelled by it. Or I've got the combination of a positive charge and a negative charge, and the electron is going to be pulled that way and pushed that way. In all of the cases there, the electron is going to go that way. It's either trying to find the source, running away from the endpoint, or doing both. We can generalize that an electron, or no, let's generalize it.
Negative charge
You want to keep going?
will always move left.
Generalize it.
In the opposite direction.
Of
The electric field.
The proton?
Likewise, if I stack a proton in any of these cases, the proton is gonna move to the right. Positive charges will always move same direction of the electric field. Again, slowly shifting from, here's my charge situation, I throw another charge into it, what's it look like? It's, now I can get to the, I have an electric field here, I throw a charge into it, what's gonna happen? So, if I have a positive charge and a negative charge, I know the negative charge is going to be attracted to the left in my situation right here. I have two explanations for it. Number one, opposites attract, positive charge is on the left, negative charge goes towards it. Is attracted towards it. Number two, I have a positive charge on the left. Where the electron is, it is experiencing the electric field from the proton moving to the right. Negative charges move upstream, and so it's going to move to the left. It's going to be forced to the left, I should say.
What if the electron, or what if the proton or the positive charge is just on the opposite side?
I just changed some left and rights there. The electron is still going to be attracted towards it. The proton is giving out an electric field where the positive charge is. Rewind. The positive charge is going to create an electric field going to the left, where the negative charge is. Negative charge is still going to go upstream.
Okay.
We will ultimately end up with 4 different explanations for why this happens.
All of which are wrong. No.
Good enough to put a man on the moon. Person on the moon. Okay, have any women been on the moon? Still not yet. Someday. Perhaps before I die. All right. Have a wonderful day. See you Monday. We have covered almost all of chapter 18. So if you got the time, I'd recommend working on the master set for chapter 18. Or if you don't want to take the master set on, they got homework problems there that you can practice, because we'll eventually have a quiz on chapter 18. And it'll take 2 of those homework textbook problems. Now, for the people who haven't had me before, and potentially Ethan, people who did not have me last semester, the number of problems that I have listed from the textbook, they have changed the numbers, I have not. So if you want to know what the actual question is, if you go to the solutions, the question is there right before the answer.
Is the master set have a due date? Or-
No. I think I had to put one down on the syllabus, but I will probably never look at that again. I had to put down a date, but
Are we gonna bring back the ancient sheet of paper that's gonna give us?
yes, we will bring back the ancient sheet of paper when we actually have something officially. Well, we do have something officially too, because we've got yesterday's lab due next Tuesday.
Okay. Speaking of.
Yes? Oh, you want to get rid of, oh, that's right, you 3. The rest of you, stick around or not. I need to talk to them.
So, when we did labs, I had you, we didn't do lab reports.
Not formal lab reports.